Hello, my dear aspirants. How are you? Welcome to Concept Clarity. I, your favorite RK sir, am going to launch the new series that is Organic series. So, are we ready to begin? Chalo, let's start. So, first of all, here I present you our first topic that is IUPAC nomenclature. Okay. So, basically, what is IUPAC nomenclature? IUPAC. I stands for international, U stands for union, P stands for pure, A stands for applied, and C stands for chemistry. The IUPAC is the International Union of Pure and Applied Chemistry. This is an international committee which sets different standards in chemistry. You know, chemistry is widely spread up into different parts. So there are some rules to name the compounds or to decide the physical quantities. These set of rules, these set of names or the naming or the nomenclature rules are defined by this international body called IUPAC. This union, okay, this union lays the rules for naming or nomenclature of compounds. Okay. So now, before we start the naming of the compounds, it's very important to know the word roots. Okay. Now you will have a question that, sir, what are word roots? No worries. Let's see. We consider a carbon chain while naming the compounds, right? Or any sort of a compound chain we consider it. For example, if the number of carbons in that chain is one, only one carbon, the word root of the parent carbon chain, the name which we give to the parent carbon chain is meth. For two number of carbons, eth, 3, prop, 4, but, up to so on till 10, that is dec. In the JEE syllabus, you are only asked, or in any engineering syllabus, you are only asked the word roots till 10. So make sure that you learn them all. Okay. Now it's all basics. Everyone knows that carbon single bond carbon. If we have carbon single bond carbon, the prefix that we add to the parent carbon chain of the word root is ane. Ane. If it's a double bond, then we add ene. If it's a triple bond, then we add yne. Now, the interesting fact is that do you know the bond strength in decreases from top to bottom? That is, alkane is the bond of alkane is less stable than the bond of alkene is less stable than the bond of alkyne. But do you know that the bond length increases in the exact opposite order? Like the carbon double bond carbon is the largest bond, has the largest bond length. Carbon double bond carbon has the second largest, and carbon triple bond carbon has the smallest bond length. This is because this is due to the strong attraction forces created by the bonds, as the number of electrons involved in the formation of bonding, in the formation of pairs of electrons are more. So more, a greater extent of attraction is applied between the two carbons. So the distance of the bonds becomes smaller and smaller. But as the nucleus are getting too close, focus on the point, as the nucleuses are getting too close, these carbon atoms, both the nucleus of both the carbon atoms apply a magnificent force on the electrons, making the bond very difficult to break. Thus the bond strength increases from top to bottom, but the bond length increases from bottom to top. Now let's see, we have different functional groups. Obviously, if we are taking considering a chain of carbon, like in any, you can consider any chain, we go through various functional groups also while naming them. So let's see. First we have aldehyde. You can see the structure on your screen. The suffix used for aldehyde is al. Second is ketone. This is the structure of ketone, and its prefix is one, on. Its pronunciation is OWN, own, but we write it as ONE, own. If if the ketone is not playing the role of a main functional group in the chain and it is used as a substituent, its name will be oxo. I will tell you why I am saying that if it's used as a substituent in this lesson further. Now let's see carboxylic acid. Its prefix is oic acid. Amines. Amine. If used as a substituent, we use it as amino. Amide is directly written as amide only. Alcohol is written as ol and has a suffix of ol. And if it's used as a substituent, its name becomes hydroxy. Naming of ether. This is the structure of ether in front of it. We write it as alkoxy alkane. This oxy is the word of main focus. If you do not use the word oxy in the name of the ether, the name becomes wrong. Now, ester. The suffix used for ester is oate. I hope you understood the content till now. Now let's move further. Nomenclature rules. First, the longest carbon chain is to be numbered. You take any carbon chain to number. Let there be n number of carbons in it. But and also consider that n number of carbon, the chain having n number of carbon, has n number of branches also. But you have to select in these many chains involved in that single carbon compound, you should select the longest one. The longest chain is always considered or numbered to be the parent carbon chain. To identify the parent carbon chain, you should focus on three things. First, it should contain the maximum number of carbons. Second, it should contain all the functional groups involved in the compound, or at least maximum number of functional groups. And third, it should contain the maximum number of double bond and triple bond involved in the compound. Thus, these three parameters decide your parent carbon chain. Let's move to the second point. The numbering priority for other groups attached to the parent chain. Yes, the numbering priority. Functional group has the most highest priority, then double bond, then triple bond, and substituents have the lowest priority. Third, chota number rule. It might sound something awkward, but the rule is quite important. Now let's see. The smallest number should be allotted to the group with the highest priority. Means if your functional group, if there is a compound having containing a functional group, double bond and a substituent, then the smallest number should go to the functional group, then the double bond, and then the substituent. Fourth rule, Kaka Kaku rule. This might also feel something not so relevant, but yeah, this rule is also very important. Just focus. The double bond or triple bond must be numbered by two consecutive integers, and the small number of both denotes the position of the double bond or triple bond in the parent chain. A bit confused? So much of English? Don't worry, I will explain. See, whenever you have a compound, and let's suppose you have a five carbon chain, and there is a double bond in the middle. Okay. The statement or the rule says that the double bond or triple bond must be numbered by two consecutive integers. Means if the double bond should have the number of two consecutive integers. That is, if the first carbon of the double bond is number 2, then the second carbon should be numbered 3, not 4 or 6. I hope you get the point. And what the rule says next, it says that the smaller number of the both denotes the position of the double bond or triple bond in the parent chain. Means if we consider our example again, then the position of the double bond in the 5-member carbon chain is at the carbon number 2, not 3. You should give the smallest number of the both numbers given to the double bond or triple bond. Okay. One more important thing, friends. You might get a question wrong if you give space. The IUPAC nomenclature rules say that you should not give the space in any word while naming an IUPAC compound. Let's see some examples. This is a straight alkane chain having 5 carbons. We have written the word root, means the word root of the parent carbon chain, and the suffix, that is "ane", as it contains all single bonds. Now let's see here the functional here. Now it comes the carboxylic acid functional group. As you can see that carbon double bond oxygen and an OH group attached to it adjacently. Okay. The carbon containing the carboxylic group is numbered 1, and the name goes as pentanoic acid. See, it's a pentane chain, 5-member carbon chain pent. It contains all single bonds in ane. And why have we not written E here? See, the rule says that the IUPAC nomenclature rule says that if we are adding a suffix after a suffix, then the last letter vanishes, and the new name of the suffix and the new suffix comes. That's why ANE is not written, E is skipped and is replaced by oic acid. Third, see this functional group. It contains two functional groups, a ketone, a double bond, a triple bond, and a carboxylic group. Oh my god. Now see, in this compound, we have to see that the functional group gets the lowest number and the functional group of the highest priority gets the lowest number. According to the priority of functional groups, aldehyde has more priority than the oxo group. So we have numbered it 1. Then the double bond, then the oxo group, and then the triple bond. Okay. So the name goes as at the 4th position in the place of a substituent. You remember at the time of seeing the functional groups, I told you that if you see a ketone as a substituent, then you should name it oxo. See, here's the use. For at the position 4, we write oxo, then the word root of the parent carbon chain, that is hex, as it contains 6 carbons, then you should number the substituent. Now two more substituents are there, double bond and triple bond. You should name the substituent that has its first letter coming early in the alphabetical order, that is ABCD. So in the case of E and Y, E comes first, so we will first name the double bond, that is 2-ene. The smallest number should be used to denote the position of the double bond or triple bond. Dash 5 ionic acid. My mistake, it's written 3, but it should be 5. Please correct it. 4-oxo hex 2-ene 5 ionoic acid. One more thing, if the triple bond would be replaced with a double bond, so if any quantity, that is a double bond or triple bond, repeats multiple times, then use di, tri, tetra, penta, hexa, and so on. It does not repeat more than 4 times, but yes, you can use. Now I am giving you some questions for homework. You have to answer me these questions on my mail ID, that is conceptclarity9999@gmail.com. I will provide you the answers and the, I will provide you the correct answers through your mail individually. And one more thing, if you require more questions from me for the practice, you you can comment hashtag questionnaire in the comment section, and I will bring a full-fledged questionnaire question session on this particular unit. Now let's move to the next topic, functional group priority order. See, now I have given a chart here. It says the priority number, functional group, and its symbol. We won't focus on the symbol right now. You can see the symbols later, but first we would discuss the functional group priorities. At the first priority comes the carboxylic acid group. Second priority goes to sulfonic acid. Ester comes at third priority. Acid chloride comes at fourth. Amide at fifth. Nitrile at sixth. Aldehyde at seventh. Ketone at eighth. Alcohol at ninth. Thiol at 10th. amine at 11, alkene at 12, alkyne at 13. See, we have seen the priority before also. Double bond has more priority than triple bond. This chart proves the same. 14th priority goes to the alkanes. 15th priority goes to ether, then halides, and the last priority goes to the nitro group. Now you would be thinking that, sir, why are we discussing these priority? See guys, we have seen earlier above that here were two functional groups in this compound, and we were confused that which functional group should be given the highest priority. So this functional group priority order helps us to think or to decide which functional group should be given the highest priority and used as the main functional group of the parent carbon chain. Also, one more thing, these compounds, if they are used as a uh, main functional group of the carbon chain, or they are used as this substituent group, they have different names. Like the ketone group has its suffix as -one if it's the part of the main parent carbon chain or the main functional group of the main carbon chain. But if it's used as a substituent, like we have seen in this example, then its prefix becomes oxo. It is used with a prefix and it is written as oxo. So these all different functional groups have different suffix and prefix, which I would a chart of which I will be providing it in the community post section. You may please go there and check the chart. Okay. Now, the most interesting and main part of this chapter. This helps solve many JEE mains questions, or the other engineering exams also ask question on these compounds. So our topic is naming of spiro compounds. On your screen, you can see this compound. These are two carbon chain, cyclic carbon chains attached at a single carbon. This carbon is named as the common carbon. Now we will number the chain. See, there, as I have numbered, this is the correct order of numbering the chain. I have numbered this chain and it contains a total of 8 carbon. First, while naming, you should use the suffix spiro. It's compulsory, always you should use the suffix spiro. I have provided space between the names, but you do not provide any space between the names. I have provided space to give you the idea of the elements involved in the naming of the compound. See, spiro is the suffix. Now, now hold the longest carbon cyclic chain that is in the structure. The number of carbons in it, excluding the common carbon, you have to write in this bracket for the first time. So here the longest carbon chain is this pentane ring. So it contains 1, 2, 3, 4 carbons except for the common carbon. So I've written 4. Now put a dot. Now the second carbon ring, it contains 3 carbon excluding the common carbon. Write 3. Then a total of 8 carbons are there. So the word root I will use is oct, and all single bonds, so n. If it contains any functional group or something else, the name goes longer and follows the same rule as discussed previously. As I hope that you would have understood how to name the spiro compounds, I provide you these homework questions. You have to do the same thing for these. You have to provide me the answer to these questions on my email ID. Now, the next and the last topic of this chapter is naming of bicyclo compounds. Now, what are bicyclo compounds? We have seen spiro. They are fused by a single carbon atom. These are fused by 2 carbon atoms. The bond line between the 2 bridging carbon atoms is called bridge line. Now, we have a compound in front of us. Okay. Now, let's see how to name it. First thing, you noted that if any carbon atom comes in the middle of the bridge line, then give it the last number. Means if this bridge line has any another 10th number of carbon, then I would give it the number 10 and I would number the chain in the order I have numbered now. Now you would be thinking, why have I written 1, 2, 3, 4, 1, 2, 3 again and again when I first number the chain? Okay, see, the main numbering of the carbon chain is in the light blue color. The number of carbons in the smallest ring excluding the bridge line carbons is given in the orange color, and the number of carbon atoms in the longest cyclic structure other than the bridging carbons is given in the purple color. Now you would understand why I have done so. The suffix you would use is bicyclo. It's compulsory, guys. You have to always use the suffix bicyclo. Then 4. The number of carbon excluding the bridgeline carbons in the biggest cyclic structure are written here. Then I have written a dot and then we have to write 3. 3 is the number of carbon excluding the bridgeline carbon in the smallest cyclic structure. Then 0. Why 0? As there are as the number of extra carbon present in the middle of the bridge line are 0. So we have to write 0. If any one carbon is also present in the bridge line, in the middle of the bridge line, so you have to number it 1. If 2, then 2, and so on. Then finally the word root of the parent chain, that is the blue colored numbers. So we have 9 carbons in total, so non, and all single bonds, so n. If the number of substituents or double bond, triple bond adds in, then the name goes longer as discussed previously. As you understood how to name the bicyclo compounds, these are some homework questions for you. You have to do the same thing. You have to name these compounds and email it to me. I will provide the correct answers to you individually. So guys, if you like the content today and you understood the IUPAC nomenclature chapter, but you want a deeper question session regarding it, flood the comment sections with the hashtag questionnaire, and I would be bringing you soon a full-fledged question session on the chapter IUPAC nomenclature. Thank you for watching me, and a surprise waits for you ahead. One more thing, I would be sharing the link, the drive link for the PDF of the today's session notes in the description box. Please go to the description box and take the notes for your future preparation. Okay. And the surprise is that the next lesson we are going to learn is reaction mechanism, types of catalyst and their function. It would be released on the date 10 June and at 5 p.m. So a basic intro that we will learn in the chapter is that this chapter will provide you the basic information about how reaction mechanisms work, what is the use of catalyst in it, how many types of catalyst we have, and what are their functions. Thank you. Bye.